Welcome. Final presentations day 2. Teams have 15 minutes to present sort of summary conclusions of the semester, and about 5 minutes afterwards for questions and answers. That extension, you ready to go?
Yeah.
All right, I got the timer set here. So whenever you're ready.
All right, good morning. Thank you everyone for coming. We're Team Extension, and this is our finals presentation. This is our team, starting from the left: Harry, Cheryl, Anton, Thomas, and Cora. So our faculty advisors were Heather Kelly and Charles Johnson. Our consultants, Dave Solba and Ricardo Washington. So for this semester, we were designing and building a location-based experience focused on wearable technology, computer vision for the ETC Fall Festival. The story we gave for the guest is really simple. The guest is a spaceship pilot with a mission to retrieve valuable cargo. In this case, we're calling this Chi. So we'll run through a brief highlight reel of both the onboarding video we made and the gameplay itself.
Welcome, citizen.
So during the onboarding video, which is about 3.5 minutes long, the game will tell the guest about what the world is, the role they will play, and the mission objective for the game. Upon landing on Earth, they will be escorted out of the onboarding area into the play area, which you'll see just in a minute. There he is. In the beginning of the game, we allow the guests to get familiar with the controls, using their left hand to control the steering and their right arm to move forward. So their first objective is to retrieve that Chi container, as you can see in that blue container. Upon retrieving it, the game tells the guest to move further into the city for the second Chi resource, at which point the climate worsens and the storm approaches. Upon retrieving the second piece of resource, the storm hits. And so the guest is told to escape the place as fast as they can by running down the city block, at the end of which they blast off into the sky, escaping the storm with the cargoes intact, hopefully. And that is a mission success for our guests. The whole experience itself is about 7.5 minutes long. And so today we'll be talking about the prototyping that we did earlier on in the semester, some of the hardware that we've developed. Then we'll go into halves and place test feedback. Then we'll dive into our development, challenges we faced, and wrap it up with festival and the lessons that we've learned. So I'll hand it over to Cora to talk about prototyping.
Okay, thank you, Thomas. So let's do a quick review, like a chronological review of our initial weeks. This part, as already mentioned in the half, so I'll just quickly go over with it. Our first prototyping weeks, we built like simple devices that could be used on human bodies, and then we want to explore how human can interact differently with the environment. These are the prototypes, but we abandoned most of them. And then it comes to the half presentation. After the halves, we browsed through all the faculty's feedback, and then we concluded to the 4 top concerns. The first is our hardware durability, as always mentioned. And second is we are overscoped. And then also our narrative and tech are not quite aligned with each other. So that's the topic we're talking later. And the last one is we are in lack of the testing. So also after half presentation, we decided our wearable technology, like finally decided. The first hardware we're using is the B-haptic suit with the 16 sensors. So it has 2 purposes. One is for the directional indicator, because when the guests are playing our games and retrieving the Chi resource, we will provide directional cues. And then the second is after the guests enter in the storm area in our game, we will provide the environmental perception, like a feedback on your body to simulate like a strike of the thunder. And then the second hardware is the Nextile Smart Sleeve. This provides our control of our moving forward velocity. So when you stretch your arm, you're controlling the vehicle to move forward, and when you back to the neutral mode, you stop the vehicle. And then the third hardware or technology we are using is the hand gesture control with the Agile Kinect. So it's basically just for the steering and rotation of the vehicle. And after we have all the technologies, we integrated all of them into our games, our experience. Then it comes to the playtest day on November 4th. So for the playtest day, we are not testing the whole experience, but we mostly just learned how our guests are reacting to our hardware, and we want to see how intuitive it is for them to use. And this smaller but more specific, I think, observation goal is actually more helpful because we have several discoveries. The first one is our sleeves can actually work on either arm as long as it is like the sensor is placed in the right way. So we don't have to worry about if the guest is left-handed or right-handed. And second is we need to modify the sleeve to make it more adjustable to fit different sizes to different people. And the third is many people, including Professor John Dessler, have mentioned we should provide UI feedback or UI tutorials on our velocity/rotation control. And then I will hand over to Anton to talk about our development.
Thanks, Cora. So we were faced with many different design challenges over the course of this semester. The major problem we faced was deciding whether to make this a single-player or multiplayer experience. Of course, we wanted as many guests as possible to go through this for festival. However, there was a major imbalance of experience quality between the two roles that we had originally envisioned. This mainly came down to the engineers' wearables all being built by us, which made the interactions very complex and required a lot of different system components to work, which unfortunately almost never happened. So we decided to remove the role of engineer, and we decided to do this because it would help our scope and we can focus on improving the experience of one guest. We still wanted to have spectators in the experience, and eventually we decided to call these sentinels. And we made this decision because family, friends, love to watch a group member of theirs succeed or jokingly fail. And as sentinels, they were able to have, as they were positioned at the back of the room, a better view of the room as a whole. Therefore, they could alert the pilot to other elements they may not see, either as a helpful source or as a hindrance. Another challenge came in the form of overly complex world building. We tried to condense too many themes into too short of an experience. And these big themes included things like climate change, the problem of constructive versus destructive characteristics of powerful man-made energy sources, technology in a post-humanist civilization, and the challenges of humanity being an interplanetary species. So the gameplay did not match up to these themes, and the goal became unclear as a result. So what we decided to do was instead reduce the contextual knowledge dump delivered in the onboarding and replace it with more reinforcement on the stakes of the goal. So this was, Chi is humanity's saving grace and our last hope of survival, so the guest needs to succeed in their mission of collecting it all. And we also reinforce this during gameplay with audio and UI elements, as you can see here. I'm now going to give you over to Harry, who's going to walk you through how the level design evolved throughout this project.
Thanks, Anton. So, as we mentioned, we changed a lot about our story to more fit into the festival. So there must be some changes based on the story corresponding to the game level design. So the first challenge we have is the time constraint in the festival. So as we know that the ETC festival is a 4-hour experience, that all the guests will experience almost all the experience as fast as they could. So a game that probably make the player to stuck at the area for a while, and probably, or even to make the player to retry multiple times, seems not really fitting to the theme. So the key point is the guests need to have a good experience at the first round. So that's how it changed. So looking at the left, it's our initial paper design for our level, which is massive and overscoped. It has a relative larger gaming areas for players to explore and searching the chi resources. And also there are so many nonlinear spaces for player to actually searching to experience a feeling of searching those valuable resources, which is unpredictable because how fast they can search it, it really depending on how good they are understanding our new control mechanics, our level mechanics. And also all the experience are task-based, which is if the player cannot finish objective A, he cannot reach to the objective B, which is we cannot control the overall game experience time. And how that we change? We make the map smaller, which is more suitable for the story and also fit into the festival. And also, we reduce all the nonlinear space to be a fully linear experience so that we can control the overall experience time and keep the player to have a good experience. And also, all the task-based experience is shifted to the time-based experience so that player will keep going forward and keep making progress to finish the game experience at last. There will be no failure cases. And next challenge we face is, we found it during the playtest day, is that the player felt like it's difficult to navigate in a tight space, and also because we don't have a reverse mechanics. The good example is when they're getting stuck in some dead ends, it will give them a really hard time to get them out of it. And if they try multiple times and still cannot make it, they will get frustrated easily. So here's a good example how we change it. You can see from the left, our initial design, there's so many sharp turns, like 90-degree turns, 180-degree turns, remove them all. So instead, we changed it to be a more smoothly and more straightforward curve, more like a slope. We want to keeping the core fun of our game experience is manipulating the vehicle and exploring the planet. So in this modified world, player will feel easy to navigate and still have a fun to playing with our new game mechanics. So let's welcome Shell to talk about our technical challenge we have faced and how we approach it.
Thank you, Harry. So while working with hand gesture recognition in a low light environment, we encounter issues like misidentification and noisy data, where bright surfaces or faces were sometimes identified as hand, as you can see here. And on top of that, hardware integration with Unity presented a lot of challenges overall, such as interference when trying to retrieve data from multiple hardware devices and connections dropping unpredictably. So to address those issues, we implemented an autopilot mode, where developers in the back can take over vehicle control or assist the player when they encounter difficulties. So this is the fourth monitor behind the structure of our play area where developers stay. And on the fourth monitor, we have this autopilot screen where we can control the vehicle, drive it for the player, change the weather in the scene, monitor hand gesture recognition, and even set the engine for our vehicle. And now I'll pass it to Thomas to go over what the room looks like.
Thank you, Cheryl. So our core structure was built up in a week. The play area, as you can see here, was built with painted cardboard. But if we had used foam core, which is what we use for the onboarding, we believe we could have set it up in 2 or 3 days. Because painting and drying cardboard takes a really long time. So this ended up being our final build. It was really important to keep the room as dark as possible to create the contrast between the player's hand. As Cheryl mentioned, it can sometimes misidentify other objects as hands in the background. As for the virtual scene, Harry, Anton, and Cheryl put a lot of effort into bringing this to life, primarily by using pre-made 3D assets and using the fog and storm effect. So for the festival, we had I think we estimated about 80 people come in. We had 10-minute slots for every guest, but we were able to host 3-person parties at a time, though only 1 person could play. We also allowed spectators to come in freely to watch the gameplay. Key takeaways: augmenting elements of human physiology, really hard. We have to develop something that is new and exciting, but also familiar enough to learn really quickly. But I think it was really a valuable practice in taking the stance of an inquisitor and asking a question, as opposed to just being a problem solver and servicing a routine that we're already familiar with. The clear design vision would have really helped in focusing on a very specific mechanism, as opposed to working off of vague ideas like it'd be really cool to be a Superman. But we're still very excited about the result of this this project, in that we created something, a unique control movement that could be potentially expanded upon into a larger themed wearable device and experience. So as a closing note, we just want to thank Dr. George Sun from Nextiles, who really helped us infinitely with all kinds of hardware and software support, and Christine Barnes, who came in for both softs and hard playtest day and the finals to give us really good, timely feedback to get us ready for the festival. So with that, we're open to questions.
So I'll ask the question I asked you at Softs. Why do I want to control a car with my arm?
And I was thinking about that question in my head today, this morning. So yes, we did get a couple of people come up to the needs in that kind of future scenario. And so while we also understand that the need of the festival was very much on the present, I think we were trying to push ourselves to create that kind of scenario and create a hardware that essentially fuels that vision and bring that future that we imagine to the present. So if you want to add anything to that.
I think also there's always an interesting experience with handling a vehicle. So when people, even in cars today, talk about vehicles, they are extensions of ourselves. So when you're driving and you're in a collision, that person will say, oh, they hit me rather than they hit my car. So trying to take a context which we already feel very connected to a machine as an extension of ourselves and put that in a future context, that was another decision why we chose to have you handle a vehicle.
I'm kind of curious for the changes you made between Softs and Festival. Which ones, when you watched it in Festival, you're like, oh my God, I'm glad we made those changes? And I'm wondering if there are any changes you, having seen Festival, you're like, oh, we should really do that to address some issues as well.
So I think the first one was deciding or finding a way to give spectators a role, because it was really weird having 3 people come in and onboarding and then tell them that this is only going to be one person. Because everyone was like, oh, really? Okay. So I think making them feel like, all of them feel like active participants was a very important change that improved our experience, and some people took it very seriously. I think something, was the second half of your question, what we wish, or,
Yeah, basically, having seen Festival, what were the short list of things you would fix immediately?
I can take that. So we really needed more people, which we didn't expect. So at first we thought we can have one person going, like bring guests into the onboarding area, and then one person sitting in the back, just monitoring everything. But we ended up needing like 4 people actually. So someone at the door greeting someone, and then like one person suiting them up. So I feel like that's a process we would have changed if we knew that would be the case.
One more? Thanks, team.
Hi, we are Team AI Wonderland, and we are making an educational AI tool for Alice platform. This is our team members, so Dimitri, Evgenia, Penghua, and Jason. This is our clients, Daniel and Melanie from Alice. This is our instructor, Tom and Heather. So Alice is a free and open source educational programming platform developed by CMU, and users can create stories and games by dragging and dropping the code blocks rather than the traditional text-based codes. So our client requests us to establish a general AI-assisted workflow to enhance Alice's creative word-building potential. After researching Alice, we found that sometimes students can't find the 3D model they want from the Alice gallery, and that's because the Alice just have limited 3D models, and the importing format is limited to DAE format. So after that, we proposed to make a 3D model generation tool using generative AI, which led to infinite content creation to better meet our clients' requests. So our final deliverables are these 4 parts. The first is a working demo. The second is a UI prototype, and third is some 3D models, and finally is tech and design documentation. Here's our workflow. So this is a teacher teaching programming using Alice, and this is a middle school students who want to use Alice to build a scene with unicorn and moon. So she typed in unicorn in the Alice searching area, but there's no result, so she used our AI tool to generate a 3D model. So she typed in the item description and then choose the art style and randomize some detailed description. So after click the generation button, she can see the generation progress at any time and the waiting time she has waited. So after the model is generated, she's very satisfied with the model, and she can use our tool to import it into Alice. So after that, she wants a moon in the scene, but the moon in Alice gallery doesn't fit his request. So she find a moon model on the internet and import it into our tool and regenerate the texture for the moon. So she typed in the model description and the art style and also the detailed description. And after generation, she's very satisfied with the textured model and importing Alice. After she finished the scene, she's praised by her teacher, and it's like, okay, thanks. Also, we will talk about our progress after halves in these 3 parts. The first is UI UX with playtest, and second is tech, and third is art.
So after halves, we developed 3 how might we questions. First is how might we display the AI tool in Alice for our core user group, which are students from 12 to 18. And second is how might we guide users to provide solid prompts for AI tools. And third is how might we use the AI tool to solve potential problems inside Alice. So based on these 3 how might we have 3 main functionality in our final tool. The first one is 3D model generation, and the second one is import model, and the third one is the model library. And now I will go into details to talk about how the playtest serve us to design those 3 functionalities and some features inside our tool. So we hold several rounds of playtests. One of the main one is on the playtest day, and we have around 25 testers, and 50% of the testers are our core user group, which are students from 12 to 18 years old. So during this whole playtest, we let the users to type in what they want to generate it, and we analyze all the results that these users created. And after go through all the results they created, we notice that when users are input words less than 10 for the model description, the results would be so much more better compared to users who put words more than 10. So based on this, we decided to create a better guide for users to input these model descriptions. This is what it looks like before we redesigned this. You can see all the input boxes are on the same page. So after that, we decided to separate them into 3 different pages. On the first page, users can type into 3 words to describe the item that they want to create by using 3 nouns. And then they could choose art style. And also after that, the final step is they can input 10 descriptive words to talk about what they want the object to look like. And at the same time, we want to users to be more patient during the generation process, because as we all know, we cannot control how long AI tools is going to take to generate the 3D models. And some users, they might be just feel impatient and they want to stop it in the middle of it. So we created two A/B tests. On test A, we have like a time counter and a progress bar, and also status updates for model generation. But on test B, they don't have like a time counter, so users cannot see how long it takes to generate the model. So during the playtest, we could clearly see when users know how long they've already waited during the generation process, they're less likely to cancel the generation process because they don't want to waste like the time they spend it when they know how long it takes. So based on this, we redesigned the generation process and we add a progress bar. And also we add like a time counter to show users how long they've already waited and some status update. And at the same time, we decided to serve users this tool as like a plugin. It's located inside the My Gallery parts of Alice platform. We also have some side functionalities, such as the model library, which we could provide users to customize the model and let them to change the appearance of the model. And they can add it to Alice Gallery after this. So in our final playtest results, we let users to rate it how satisfied they feel about our whole tool and the model quality. The total score is 5, and 100% of the testers during the final round, they rated a score equal or higher than 4. It's a high improvement compared to what they rated us during the playtest day. And here are some images that they created in the final round of the playtests.
We looked at multiple different AI models. We were considering which one to use. So Get3D and DreamFusion are very powerful models. However, they require very high-end GPUs to run, and we would have to run them on a separate server. And also their generation time, at least in our testing, was on the order of like tens of minutes. Then we looked at Shapey, which is a very lightweight model that we could easily run on the client's machine. And it takes around 20 seconds to generate per model. However, the quality is very poor and it doesn't generate any textures. Finally, we considered Meshy, a web API that costs around 12 cents per model and has pretty good quality and takes a couple minutes, 3 to 4 minutes per model, which out of all the AI models we looked at was quite good. So our tool lets the user generate 3D models, retexture existing 3D models, browse all those models in a library, and finally import those models into Alice. When the user generates a new model, they first enter a description of the object, for instance, race car or apple or spaceship. Then they choose one of 7 different art styles, for example, realistic hand-drawn or Japanese anime. Then they enter a description of the appearance, for example, shiny, red, metallic, or rusty. Then we use a Python script to send all that data to Meshy, and after a few minutes, we download the model. And once the model is downloaded, it appears in the user library along with any other previously generated models. Meshy generates a snapshot of the model, which we show, and the user can also type in a name for the model. In addition, the user can upload models from their own computer into this library. Then the user can select any of these models and retexture them, which will keep the same mesh but generate a new texture, and the old model and the new model will be shown side by side in the library. And finally, the user can finally import any of these models into Alice itself. When retexturing a model, the user has all the same inputs as when generating a new model. However, they're highly encouraged to enter completely new values for the object description, art style, and appearance. Since Meshy refers to models by their URL and requires a URL when retexturing a model, they're gonna, when the user uploads their own model, they have to generate a new URL for that, so we use our own file server to do that. And then finally, we can import the models into Alice, and we use Alice's import model library. And then the user can enter a name, scale the object, and rotate the object, and finally add it into the gallery, and then use it in any of our worlds.
All right, so besides the main functionalities that Dimitri just talked about, we also implemented several user experience supporting features. First thing, we have our randomized description. So because it is hard for users to understand what texture description is about, we have tested dozens of different inputs and then picked 8 of them that works the best. So in the cases that users don't know what they should type within the description box, they could just press a button and use a randomized generated prompt or like edit it based on their needs. Second thing is the progress window. So after we start generation, there will be a tiny progress window pinned onto the top of everything. This enables players to work on their things while still being able to see the current progress of the generation. Third thing is the language filtering. Because we understand that the main use case of our tool and Alice is within the educational field, and our target audience are mainly middle school and high school students. So we added a list of prohibited words that will auto-delete any prohibited word detected based on the item description. This prevents the generation of any not suitable for work items and contents. There's one more thing that is worth concerning about while creating our demo, which is the generation model quality. As you can tell here, Meshy has greatly evolved within the last 2 months. The prompt here is legendary stuff, fantasy, game assets. While 2 months ago, there are in total of 4 different inputs, which are object description, texture description, negative prompts, and art styles, and the generation progress is pretty slow, and the overall outcome is not controllable. While currently, Meshy only takes 1 single input, and it will generate 4 different rough models for you to pick from to refine, and then to create a more detailed version. And overall generation speed is pretty faster.
Okay, let's talk about the art part, because after half, we need to spend some time into creating a working demo, and as you can see, neither our clients nor us were satisfied with the model quality generated by AI. So after half, we came up with the idea of adding popularity requests handmade 3D models with AI texturing into the library. We sent off a survey of what were the most wanted model themes by users. And one of the most popular themes was Wonderland. So based on this theme, I made several models that can be textured by AI. And when making models, we found that model cannot use the UV made by AI. So we have to unwrap the UV by our own hand. And this way, when we change texture with AI, it doesn't stretch the texture. You can see the difference between different UV in the PowerPoint. And here's the example of good UV with unwrapping. And you can see the mapping will not be stretched at all. And here's our handmade assets art library. I'll walk you through it now. And like we mentioned before, all these models are UV unwrapping, handmade models, and user can always reduce the AI texture part with our tool. And we provide a large number of assets needed for the environment, such as trees, and for different seasons and houses with different themes. User can choose whatever they need and like. And here's some flower and Wonderland theme mushroom. And switching art style is also a big problem for user and artists. Here with the AI, we can making advanced UV unwrapping assets have different art style. This gives the user especially more freedom. Here's some example of our handmade assets. And here's some more example. And here's a showcase of the environment building Alice using our own assets. So the user can build the exact same environment, but in a different style by using our tool.
All right, so here we have our takeaways, but we don't really have time to talk about that. And I'll just talk about the summary. So we designed a 3D modeling prototype pipeline for Alice, and it is currently based on Meshy, but it can expand to other AI tools in the future. Our product is an experimentation in the possibilities for AI implementation within the educational field. And even as we're presenting here, generative AI tools are still evolving. Better and faster models are being developed and published daily. And that's it for our presentation. We're open to questions.
In the opening, teacher and student, the student did a number of things. I wasn't sure if that was a mock-up or if that's the way the tool really sits now. Could faculty use your tool stack and do what that student did in the start of the presentation? And how long would that process take?
So I would say in general, after installation, if you want to use our tool, the overall generation would take from 3 minutes in general to maybe 5 or 10 minutes based on the current queue within the Meshi server. So yeah. Any more questions?
I'm curious, so this could potentially be a very big change for Alice going forward. I know Roblox is exploring very similar kinds of content creation for kids. A lot of people are talking about the power of being able to use AI for content creation for kids. Do you think this is likely to be a permanent part of Alice going forward?
From our point of view, we would say that it is potentially possible, but from the time that we were developing our tool, we believe that the current generative AI models are still not good enough to put into production, so that this is more or less in experimentation. But in the close future, like maybe half a year or like a year, I think that the generative AI tools will be much better, and the models could be actually much more good-looking so that they could be put into production. Yeah.
Thanks.
Hey, a lot of the models that you showed are relatively common objects that we might expect people to look for when building an experience. How good is the engine on generating very strange things that people might request, like a spaceship made out of bananas or something, you know, something more extreme that kids might be asking for?
Yeah, so like we just said, we added a word limit onto the item description just because, in general, Meshi currently cannot take onto any objects that is a combination of, like, for example, 2 or 3 different objects, like a banana spaceship, as you just said. So the generation would be pretty bad, to be honest, for now. I think it doesn't really understand, like, the prompt. And yeah, but like in the future, it could be possible, but
Hi everyone, we are Team Fashion Next, and this is our final presentation. And firstly, I would like to introduce our team. I'm Ariel He, the producer, and this is Marie, our experience designer, Abigail, the UI designer, Jin Kun, the solo artist, and the last one is Luca, our solo programmer, And our faculty instructors are Charles and Brenda, and we also have a subject matter expert, Eric. So at the beginning of the semester, Charles tasked the entire team a question. He asked us to focus on the waste issue in the fashion industry and create an innovative product that addressed such an issue. And we ended up attempt different idea, and we came up with a gamified installation that stimulate an in-store experience with a personal shopper. And the goal of our product is we are targeting an eco-minded shopper, and we are trying to raise awareness of how much positive impact can be caused if you shop sustainably. Marie will talk more about our experience.
Thank you. So for our installation, we created an in-store experience that simulates a guided shopping experience with like a personal shopper. So first of all, the guest will come in, the facilitator will welcome them into the store, and they will hand them a phone. And on this phone is a survey that will give them a goal for the whole installation. And for example, it would be like, today you're going to go to a concert and you're going to put together an outfit for that event. And your sustainable shopping goal when you're looking for an outfit is to save water. And then the guest will go over to a rack of clothes and they'll pick out their outfit. And when they find what they want, they can scan the tag on the clothing. And this will lead to an interactive visualization that is specifically for that garment. And so here's a quick mock-up of what the whole store would look like if we built it. And here's a demo of us going through the actual experience that we built.
Hello, welcome to the Fashion Next store, the newest way to shop sustainably. Are you ready to go shopping? Yes. Okay, great. So first, we'll give you 2 quick questions so we can give you a personalized outfit challenge.
Okay, so should I just do the survey? Cool, so I'm going to a hiking trail and my sustainable shopping goal is to save the planet.
That's great. So these are the clothes we have, and this is the tag on the clothing that will show the different types of sustainability. And if you want to pick this piece of clothing, you can flip it and scan the QR code here.
Okay, cool. I'll explore it.
So based on everything we learned, we decided on 3 goals for our installation. The first being helping the guest understand what sustainable actually means on a garment, and also being able to interpret that in a visually appealing way. And finally, to make a software template that can be further developed in the future. So, Abby will talk about the first goal.
Our first goal is to help the guests understand what sustainable means on a garment. And we have 4 different icons to represent 4 different sustainable types, and they're all matched with the guest's sustainable goal. For example, if the guests need to prevent waste, and then they need to find the clothes that is biodegradable, and then how we let the guests find and match the corresponding clothes and understand the meaning of the sustainable type. First of all, we have a tag hanging on the clothes, and on the tag we will show the sustainable information of the clothes. And when the guests see the information on the tag, they can decide whether they want to choose the clothes based on their own judgment and flip the tag to scan. And second, the kiosk will show more detailed information of the sustainable type, and during the display of the information, the corresponding icon will show on the upper left of the screen to let the user, like the guest, better understand the meaning under the icon and also the sustainable type. And lastly, when the guests return to their phone, we also use the icon to represent the brief information of the clothes that help the guest to quickly remember the sustainable type of the clothes. And since our experience need to switch between 2 devices, and during our playtest, we found a lot of guests don't know where to look when switching device, then we add a UI transition. Our experience began on the phone, and after the guests complete a survey and scan, and the UI will tell them, please check the kiosk for more information. And because the position of the clothes and the screen is fixed, then we use an arrow to point out the kiosk screen to let the guests see the screen more intuitively. And after the guests learn all the information on the kiosk, we have a summary page at the very end. And on the summary page, there's a back to scan button at the bottom to help the guests know they already complete all the information on the kiosk and it's time to back to their phone. And our experience is an interactive experience, and during our playtest, we found a lot of guests don't know how to interact with the screen. Then we changed the sequence of the text information and the UI. We let the text generate information of the clothes appear at first, and after the generate information, the UI will appear and guide the guests to interact with the clothes to learn more information. And after the guests complete all the interaction of this sustainable type, and there will appear a continue button at the bottom to help the guests understand they already complete all the interaction of this part of sustainable type, and they can enter to the next step. And when the guests learn all the sustainable information of the clothes, it will also show the summary page of the clothes to let the guests quickly review all the information. And when the guests back to their phone, they can also review the information on the phone. It helps the guests review and the detailed information without scanning the clothes again. And also helps them to make a comparison between different clothes. If the clothes they submit doesn't meet the goal, they can choose the one they don't want and delete it and scan the new one.
So our another goal is to interpret sustainability and convey information in a visually appealing way. So first, we want to show the natural material used during the manufacturing process of the clothes. So when the consumer click on the part, it will split and zoom in. And for the water conservation section, we choose 3 visual elements: the water pouring effect, and the grass growing, and the tree leaves turning green. The water poured represents the water saved during the manufacturing process. And in order to show the biodegradability of the material, we choose day-night cycle visual effect to represent the flow of time. The consumer drag a slider bar to control the time, and the clothes on the ground are attached to a material that gradually dissolves over time. And finally, to show the durability of the material, we used control rig to simulate the fabric physics. The consumer can swipe on the screen to drag on the clothes.
So for the day-night switching, we decided to use a plugin called Ultra Dynamic Sky. It provides us more smoother switching of time flows, and we can have more controls of the weather and the sunshine rather than the normal ones in the Unreal Engine. And for the dragging of the clothes, we decided to use control rig. So we first create a control rig based on the skeletal mesh. Then in the scene, we do a raycast to the control rig and find the bone that's connected to on the raycast. And then we input a mouse control, like X and Y axis, to control the dragging. And we also create a software template that can be further developed. So based on this data mesh data table, and you can just add a new row and input all the meshes into the data table, and the software will automatically generate the presentation you want.
So if we have more time, the next step, we would like to add a call to action feature, because right now we only focus on showing the positive impact of the sustainable shopping choice, but we didn't really have the function to actually turn their belief into behavior. And also we would like to tailor our experience to a specific client or a specific location to test if the software template really work and test if this idea is universally applicable. Looking back to our project, here are 3 things we learned from this semester. The first one is for an exploratory project, you may take a lot of pre-production time kind of navigating the topic, but if we redo this again, we would like to draw a clear timeline to set the boundary between pre-production time and actual development time. And the next thing would be, since we are exploring a very broad topic, so no answer is right answer and no answer is the wrong answer. And we also have multiple designers on our team, which is make it really hard to make design decisions. So if we go back to the beginning of the semester, we would like to create a creative decision-making structure where select one of us as a creative leader. So when it's kind of difficult to make the call, we know who will be able to do that. And finally is, besides the project metrics, we would like to set up a successful metrics at the beginning of the semester so we know if we are heading towards the right direction. And I think it will also help the entire team to stay motivated throughout the semester. And that's all of our presentation. We are open to questions. Thank you for listening.
I was wondering if you could talk a little bit about, this wasn't normal tech art that you had to do. It was a bit of information that you had to get across, and it kind of transitioned to a user experience and UI elements at the same time. Can you talk about how that's different than the tech art you might typically do?
In this project, we implemented most interaction with the material system in Unreal. So for me, I need also to cooperate with the control rig system, which is typically different as a Euro environment art in my own project. So that's, I think, the animation system might be the most biggest difference in this project as the Euro tech art for me.
So I know that that clothes are made of natural materials are a lot more durable and are a lot more better for the planet. But in the majority of the cases, they are also a lot more expensive than synthetic materials. And I was wondering if you had any design decisions that would address that issue, or if you just if you guys decided to focus on other parts of it.
So I think we already solved the design issue by selecting the audience we are targeting at. So in our case, we are targeting eco-minded shopper, and if I give you more detail, it would be young adults have disposable money, care about the environment, but don't have enough knowledge and information to actually identify those sustainable fashion choices.
Yep. So late in your presentation, you had a slide about lessons learned. One of them seemed to imply that the team overall either found the topic a little difficult to grapple with or weren't really fans of fashion. I don't want to put words in your mouth. So if students at the ETC find themselves on a project that on the surface doesn't really engage them, do you have suggestions about how to solve that?
That's why I think setting up the metric for success is kind of important, because a lot of time I feel like students are not quite interested or passionate about the project, not because they are not interested at the topic itself, but because they don't know if they are doing the right thing to navigate under this topic. And since, the project takes 14 weeks and you just couldn't get the answer from the beginning of the semester, so if you have a matrix for success and the team is knowing that they're doing the right thing, we're heading towards the right direction, and every team member is using their expertise to contribute to the answer of the project prompt, I think that will make a lot of difference.
So without familiarity, you're saying it's hard to know whether you're making the right decisions.
Yeah, kind of, because you have different answer, but which one is the best one, which one is the right answer, that's the hardest part. Finding the answer, finding the answers to the prompt is not the biggest challenge, I would say.
Thank you.
Hi, we are Team Espresso, and this is our team. I'm Yuxing, and this is Patrick, and Polly, and Yichen. And our instructors are Jonathan and Scott. So first about our project. So our project is a short narrative and mechanics-driven game that provides an expressive interactive experience that is iterated on multiple rapid prototypes and playtests. And our final deliverable is a 5 to 10 minutes gameplay for the guests in the festival and incorporated with all controllers. And this is our playthrough video. So our project has a full narrative, a story for our game, and the following is our part of narrative.
Igor, I have had a prophetic vision, a guide from fate itself for my next revolutionary scientific discovery, a way to create the perfect being. The creature I saw in my dreams was of astonishing strength. Bring me such parts, Igor.
So this part is our all controller, and when the player moves the token in the miniature of the cemetery, the character in the digital game follows the token, and when the player uses the shovel to dig into the gravels, there will also be feedback from the digital game. And this is the second part of our game, which is body assembly, and we chose touchscreen for this gameplay. And next, Anna will talk more about our project.
Thank you, Yushin. So from the get-go, one of the problems we encountered with our project was that our project description did not give us a good idea of how to approach the stakeholders, which were the ETC faculty in this case, and what was expected of us for this project. So one of the problems was that the term expressive interactive experience has, there are many definitions of what expressive might be, and talking to more faculty members, we realized that everyone kind of has their own definition of this term. Two other terms that often popped up when talking about the mechanics or the alternate controllers is unique and interesting, which are also very broad terms and are basically saying, make this good. So because of this, we tackled this problem by making our own definition of what an expressive or unique experience might be. And so our definition is that a unique experience is something that makes the player feel uncomfortable and strange while also still being fun. And with this new definition, we also gave ourselves deliverable goals that are based on the project description. The project description stated that this should be a game that could be submitted to festivals. So we made our deliverable goals to be presenting at the ETC festival as well as submitting to the Alt Control Festival because of the alternate controller component. So once we had those definitions and goals, we decided to settle on a concept for what this strange and unusual interaction should be. One of our ideas was milking a cow. Another one was putting your hand in a shark's mouth. And we later settled on digging up a grave as our strange and unusual interaction. And now Polly will talk about the process.
Thank you, Anna. So here are some of our takeaway from exploring this verb. Our early prototype had a lot of problems at quarters. Firstly, you were attaching a vibe tracker onto the shovel, and the players was like digging, or rather waving the prop in the air, and there was no texture of sand or dirt to push against. And this was a major red flag because the player movement isn't really matching the verb we're trying to express. And we're also working under the constraint or limitation of this prop because very few actions can be done with a shovel, and this puts like an ambiguous in-game goal, meaning that whatever you're digging up has to be really important for the process and the player, and that was creating more design challenges than opportunities. So we as a team decided to change our project direction and focus more on the game itself and try to build a healthy amount of game mechanic and the world, as well as on the core theme, which is a combination of humor and death expressively. So with that in mind, we created our first paper prototype. And in this prototype, player would play as a mad scientist who's similar to Dr. Frankenstein and creates body using parts of corpse. Verbs such as navigating, raiding, and assembling was added to form a complete game loop. With that as our foundation, we moved on to worked on a digital prototype, which was presented by halves. And this prototype includes the basic script of the game loop, our assets, narrative design, as well as level design. And a little bit more about this is the player would play as the resurrectionists, who were based on a real professional body snatcher that operated in 18th to 19th century, who stole body parts from cemetery for medical research. And we've kept this premise we used for earlier prototypes. And this was presented in halves, and it raised a lot of concerns, and we received a lot of questions regarding on how alternative controller could be implemented in this project. And now Patrick will talk about that process.
All right, thank you, Polly. So after half, you guys really talked a lot about alt control. Now we really started to get into alt control. So first of all, we're thinking about probably possible alt control options. First of all, using an air mouse. The idea was kind of having the air mouse point at a location in the game and then have the character move to it. But the problem with that is it doesn't really feel alt control. You're just using another mouse and then moving it at the pointed location. Another thing we thought about was experimenting with the DDR dance mat. So the character will move in the corresponding direction that the character that steps on. But then that really kind of has breaks immersion between the character and the user. So another thing that we thought about was probably thinking about using more building light sensors. The idea is having a matrix of light sensors and then having a player have a flashlight, and then the character will move in the direction where you kind of point using in the matrix of light sensors using the flashlight. The problem with this is we'll need a lot of light sensors to do this, and possibly it might be very inconsistent and inaccurate, since we don't know if every light sensor will be accurate enough to get to kind of calculate the amount of light that they receive inside of the matrix. So in conclusion, it's kind of hard for us to incorporate alt control into the current game design that we have. So another alt control option was using for the body assembly part. So thinking about having fake body parts, and then we could possibly have NFC tags built into each side of these fake body parts, and then have NFC readers on the table, set up on a table. The idea is having the body part sitting on the table, and then having the NFC readers read it, so it knows oh, this is depending on the distance of the tags on the body part, we know, oh, based on this distance, this is a hand, and then based on which tags we put it facing down, it knows the orientation of it. We can do this either for both for the hand or the head as well. But the problem is we need a lot of readers and a lot of tags for this. And then the problem is also since we need so many readers, it will definitely affect the performance of the computer, and then it's very inconsistent for knowing to calculate the correct position. Also, readers are very sensitive, so we're not sure if there will be misdetections or not. So as I mentioned, it's very hard to incorporate so starting with from quarters, it's very hard to incorporate game mechanisms into alt control. Since we started with shovel, it's kind of hard to design let's make a cool game for using shovel and digging. Also, in our current state during HAS, since we have kind of a game plane down, it's also very hard to create a perfect alt control for it. So a lesson we learned is that we need to work hand in hand and then design early, kind of start designing the alt control with gameplay at the same time, so they will fit with each other and then bind together better. So for our controller, for our project, we decided to go with a touch frame. A touch frame is basically a touch screen, but without a screen. When players put their finger into the screen, it acts like a mouse click on the corresponding area. It's very versatile and easy to set up. And then I'll let Ichin tell us more about how we incorporate this into our project.
Okay, thanks, Patrick. So let's talk about working with the touch frame. The reason why we are not using the touch frame is because the touch frame for body assembly part, because the touch frame only can detect the inconsistent distance among the points. So it cannot detect the large body parts. So based on what we learned, we decided to use a touch screen for the body assembly parts, and the touch frame will be used for the grave exploring parts. Now, for the installation for the touch frame, we split the touch frame into two parts. The majority area is the grave exploring, which we use a real map for the player to navigate the character. And on the right side of the touch frame is the grave digging. So we
want to make a real feeling of digging for the players. And also the light is important because we want the player to see the map in the dark and create a nervous environment for the players. Also, we want special thanks to John for supporting us with install the touch frame. And the game mechanics we designed for the touch frame is we use a physical symmetry map so the players can use the token to control the movement of Igor. Just imagine that the players are playing a board game. And for the digging part, we want the player to feel they are actually digging something, so we put the gravels to simulate the digging actions. And we explore two textures for the digging. One is the sand, the other one is the gravel. The disadvantage of using sand is because the sand is too messy and it's hard to clean, and sometimes the sand will get onto the map, so it will affect the detection of the touch frame, and also the sand will cause sneezing while it getting to the air. And the advantage of using the gravels is the gravel is easy to clean and it won't get on the table, so it will not affect the detection of the touch frame, and the gravel won't get into the air. However, during the playtest, we met the problem with working with the touch frame. When the player touching 2 points, there will be an extra point generated at the middle of these points. So the Igor will automatically move towards this extra point. The reason is the extra point comes from the mouse. So we found a solution that disconnect the mouse connection because the mouse has the confliction with the touch frame. Next, I will let Anna to talk about the environment design.
Thanks, Seicheng. So for the environment design, we use a mix of props and lighting in order to create the mood and atmosphere of a spooky graveyard. We used a mix of RGB lighting with reds and blues and greens in different parts of the room based on what mood we wanted to create. And we used props that we outsourced and bought ourselves, as well as the props we could find in the prop room to set up the environment for the festival. So now we'll talk about our final deliverables. So first of all, the festival was very successful. We had a lot of positive feedback from a lot of the guests at the festival. One of the interesting things we found was that it was a lot more successful with parents with smaller children as opposed to teenagers, whether or not that's because teenagers didn't want to go to the festival or some other reason. We realized that our target audience might have been misplaced in the beginning, as it was teenagers and young adults. Another thing we found out was that while we had instructions for the mechanics, we didn't really have a lot of instructions for how to actually use the alternative controller. We had to explain it out loud. And while it was successful for some of the guests, for other guests, it still left them confused. There was also an issue with interference with the actual alt controller, because if you leave, say, the shovel or the token inside of the game board, it might interfere with any other inputs that we want to create. So we had to, basically as hosts, remove those parts of the game from the game board so that it doesn't interfere with the gameplay. So we also submitted to Alt Control, which is a festival at GDC that celebrates alternative controllers, and we're now waiting to hear back from them. And special thanks again to Jonathan and Scott for supporting us this whole way, as well as the other DC faculty that has helped us with the installation, as well as with the design process. And thank you for listening. We are now open to questions.
I really love that goal you established to make people uncomfortable but have fun at the same time. Do you think you met that goal in your final design?
I think the feedback we got from the festival was that people were kind of confused about why we chose this theme, but they ended up having fun because of that unusual nature of it. So while it wasn't necessarily explicitly uncomfortable, the fact that it was unusual helped a lot of people enjoy it.
Thanks. I'm fascinated by your reaction to the prompt. I'd love you to send me an email in which the original prompt is then followed by how you would have preferred the prompt to be written, that would be great. Thank you.
So you said that you noticed at festival that kids, families tended to enjoy this more. What elements really resonated with them, and what did they not respond as well to?
I think the physical parts, like the actual token and the game board and the little props we had, like with the bushes and the toy graves, like those really helped kids like immerse themselves because it felt like a toy to them, as well as like actually digging with a shovel. And as for like the adults in the room, they usually were like watching out so that the kids don't break anything, but they were also having fun with like the story and the humor of it, as well as making sure that like the kids could finish the game and play through it the whole way.
So you guys have had a lot of twists and turns over the course of the semester. And so you've definitely learned a lot. If you could go back to the beginning, knowing everything you know now, what would you do differently?
I think that the biggest takeaway we had was that we needed to design the alternative controller hand in hand with the mechanics so that both of those like are a lot more thought out, and to make decisions early on so that we could play test them in a very simple way and understand whether or not it worked or what kind of tweaks we needed to make. We also, I think, had very different design sensibilities as a team. And so being honest about that and coming to terms with that was something we need to do early on.
Thanks, Steve.